And no, I don't want the AI companion.
Hmm.
All right. Well, does that sound like a good agenda for everybody? Go through this document and then do the things that Chris asked?
Sounds good. I also threw the document in the chat in case that's useful.
Perfect. Let's see, LTS brainstorming document. Do you see just the document?
It's working.
All right.
There we are.
I can make it work. All right. Before we start, anybody else have any other agenda items or issues that they want to discuss in this call? If not, we'll jump into the LTS document. All right. Silence is golden. Okay. So this is the document that Chris has been putting together. It's basically just a brainstorming of like, what is this thing that we're calling the long-term support for WASI P1? The idea is that we've had a lot of discussions. We've written some things down, but we've not written everything down. So Chris is trying to consolidate this into the what. And then obviously we have to figure out how much, effort this is going to be. Table of contents. Couple of things here, like what are we looking for? What are we trying to get out of this? What are our guiding principles? Some of the motivations, and then it starts talking about the things. So synchronized tool chains and runtime, what we're talking about in terms of supporting software porting and able to bring code over to LTS and get it to run inside the WASI P1 LTS. And then also, what does the future path to the component model look like? And some pragmatic stuff on the bottom. So let's jump into this. So two key benefits that he's putting forward here. And again, if there's any comments, just interrupt me, but I'll fly through this quickly. If there's anything you want to discuss, disagree with, add, just blurt it out. Because I'm presenting, I don't always see the hands up. So since there's four of us, we can just scream and yell and get my attention. The two key benefits here are stability and software portability, right? So from a stability perspective, we want to guarantee support in the long term, but we also want to make sure that things don't break over time, right? We've had a few changes, and things like Lime 1 is coming out where they're going to change potentially what the default instructions and options are. We've already had a break in December where some things were enabled. I think it was reference types and bulk memory were enabled by default in WASI SDK. That broke some people who didn't compile that by default. So by default, WAMR didn't support that. So there were some issues there. That's natural. People are moving things forward. They're developing new standards. They're pushing new features. We all want new features. But at the same time, for an LTS, that kind of works against that. So we want to make sure that there's good stability there, that we, in cases where there is an issue, such as a feature coming out that's not backwards compatible, how do we manage that? How do we manage that in a proper way? Right? Maybe that's a major revision version, and then the old version still gets supported for a period of time. We need to sort those things out. So stability is a really key benefit here. And then we want to make sure that that tool chain is fully supported going on, right? So just because WASI 1.0 gets released, the people who have built code, on P1, if there's a bug and that needs to get fixed or a security issue that needs to get fixed, we want to make sure that that tool chain is serviced, not just the runtime. From a software portability perspective, that's the other aim of the LTS, is aim to provide a stable and consistent system for bringing things over, right? So we wanted to enable as much existing code as possible and run that inside a WebAssembly runtime. Hi, Thomas. I see you've joined us. We don't really have too many formal agenda. Oh, Merlin is joining as well. We're going over what Chris had asked us to do, is basically go over Chris's document. So I'm just flying through this real quick with the team. And then the goal would be at the end is to kind of start building that work list of what needs to be done and kind of estimate some of the sizes. I didn't ask for this before. Is anybody able to take some notes? Since I'm presenting, I can't do that. You mind doing that,
Yes.
Emily?
Yeah, I can totally do that. I think I'm
Perfect.
realizing I owe notes from a couple of weeks ago. So
No worries.
yeah.
We won't judge. It takes me sometimes several days to get them posted when I do it. And yeah, since we're a small group here today, Thomas and Merlin, where I'm just jump in, I can't always see the hand up. So just if you disagree or want to add more context to any of these, let me know.
Of course.
So that's key benefits. That's what we're looking. That's like kind of the goal of why we're even bothering with this LTS approach. And then some of the guiding principles. These are things that we'll use to sort of guide how we act and how we operate and the priority of things. Don't break the runtime. So we want to preserve runtime stability as much as possible. You sort of think of this as, don't break user space mantra that Linus has for Linux. Same sort of deal here, because that's very much a similar relationship. Learn from one release, apply it to the next. We want to avoid, kind of willy-nilly making a decision and changing that and then taking a different approach and then going to do something different, right? That's natural as the standard progresses, and we've seen that in P2 and P3 in the component model. That's totally natural. But in an LTS, that works counter to what we're trying to do. We're really trying to apply that stability that we talked about before. And then again, figuring out how to adapt that, move that forward. Practicality or pragmatism over perfection. We know that not everything is going to be perfect. We know that we're not going to 100% say POSIX compatibility, but that's fine. If we strive for 100% POSIX compatibility, that's not really our goal. Our goal is to help port software and run software and have it run reliably. That does not mean we need 100% POSIX, support. What we do need, though, is be very pragmatic about what things we need to support and be pragmatic about it. Platform portability is an aspiration, not a destination. The embedded space is diverse, and it can sometimes be difficult to actually provide true platform portability. And again, talking about the one we just talked about, we need to be more pragmatic or practical about that. We're not going to unify everything. There's going to be some cases where things are just a little bit different on a different platform. And I think we're just going to have to be somewhat okay with that. Now, that could be because we have different hardware capabilities like memory restrictions, or we don't have a hard disk here and we have flash and we have to treat that different. Or it could actually be a fundamental thing that just works differently on a real-time operating system versus Linux, for example. And then also work with the parent projects. LTS inherits a lot of amazing upstream projects, Clang, LLVM, Whammer, the WebAssembly stuff, WASI SDK. We want to work with those projects as much as possible and also contribute back to those. Okay. I don't think we need to talk too much about the long-term motivations for the long term, but again, WASI Snapshot Preview 1 has a large install base. Many of us are here because we're using this in a production capacity. So we need to support. That's one of the major motivations. At the same time, we want stability. There's been a lot of churn in P2, P3 in the component model. Again, that's totally normal and expected and absolutely the right thing to do as we're developing a new standard. But those of us who are trying to build on the existing one in production want that stability. And they want that across the entire tool chain, not just the runtime. And then we talked about porting, right? So we want to be able to take as much existing code as possible and port that over.
Actually, I kind of want to hop in here because I
Sure.
see that the next thing is synchronized tool chains and runtimes. So I should know the answer to this question, and I do not, so I'm going to ask it.
Sure.
What all does the LTS encompass? Is this like, WASI interfaces and the libraries there? Is it a libc version? Is it a WASI SDK, which includes like, a compiler version? What all do we think will wind up in, long-term support? Just because it touches, WASI, for instance, ends up touching so many different layers of the stack. What all do we see is going in there?
That is an excellent question. I'll attempt to answer it with my answer, but I'm sure others have different answers. But for me, LTS, and this is the reason why I use the language, it's an effort, not like a spec or a standard, right? It's also why we're doing this in the Bytecode Alliance and not necessarily in the W3C form, right? So the spec itself is the W3C. That's going to be, well, I guess we're P3 right now. That's eventually going to go forward. That has to follow the W3C standards and all this other stuff. But that again is the spec. The Bytecode Alliance is about the implementers, right? And so in my mind, it's an effort that encompasses the runtimes, the tool chain, which includes libc and whatnot. We'll talk a little bit more about exactly what those feature mappings are. And also, yes, in effect, the spec itself, because they're tied in with the runtime and the libc. But in general, though, if you're taking existing C code, C++ code, and you're compiling it, you actually don't care so much about the WASI interfaces like FD underscore open and all FD underscore write, because you never call those. Right? You end up calling the libc equivalent, which calls that. But that is a part of that as well. So, but that a lot of that is already locked and loaded with the WASI P1 spec, right? So we don't want to change that spec as much as possible because we have wide adoption of that spec across multiple toolkits, Go, Rust, Zig, C, C++, et cetera, et cetera. So while that's part of the standard, I don't think we're going to spend much time talking about the standard. We're going to spend more about talking the runtimes and then the things that generate the code that runs in the runtime. So the full tool chain. So the libraries, the compiler, optimizers. One thing that I don't think have talked too much about, but Chris and I have, because it's an issue I'm facing right now, is how do you debug this? Right? What's the debugger scenario for that? Right? Because that's another key part of what we're doing. And printf is not the good example of how we should be debugging. Although that's kind of what we do today. But turns out you can actually debug these things. So requires a little bit of magic in getting everything up and running, but you can actually debug these pretty well today. But that story needs to become better and be well documented. And then I would say also as part of that, Emily, I would include documentation. So
Okay, cool.
anybody else disagree? Did I miss anything?
I would copy it. So you explained it quite well from my point of view.
Cool.
Okay,
Cool.
but so the way to look at this is like, I'm trying to kind of come up with the like one sentence tagline. It's an effort to maintain the WASI P1 interfaces encompassing documentation, specification, tool chains from libraries to compilers and debugging, and how runtimes interact with all of that.
Right.
Yeah.
Sweet.
And if there is someone who needs more of the WASI P1, be it something like signal handling or a specific part of signal handling whatsoever, then usually this needs to be done by the ones who need it, of course, but maybe more than one player, stakeholder needs it. And so a burden sharing can happen to some extent, right? So this is also something that can be envisioned with LTS. Mm-hmm. And also in that so Stephen, I guess you came up with the idea of having different tiers. So tiers of having support. So how many years is which feature supported in that kind of sense. This is also where we have to look at, and this is also something that where LTS kicks in, because let's face it, we cannot do it everything. It's just it's just like it is.
Yeah, I think the ability to bring existing code into WebAssembly into the embedded space, I think it's kind of good that we're on this, because I think to Thomas's point, it's more than I think just preserving the P1 interfaces, although that is part of it. But I think there's some pragmatic potential extensions to that. And I'll give a couple of different examples. Thomas gave one. It's a little bit more complicated, so I'll do that one second. But a lot of code today uses epoll. Epoll is a Linux-based modern way of doing polling. It's a kernel API call eventually. But we can actually emulate epoll over the existing kernel interfaces that we have today, right? Because we already have poll one off. We can implement the API so the existing code compiles and runs, maybe not exactly at the same performance level as epoll does, because epoll was created to be an efficient poll, hence the E. But at least we can compile and link and run that code. And so that is something that we could potentially do in WASI libc. Doesn't require changes to those interfaces. And so for a lot of folks, that would be helpful. I'm actually debugging something on my screen prior to this call that requires epoll, and I'm currently looking at this, hence the example. So adding that seems to be interesting and potential something potentially that we can do without actually making many changes. Signal handling is what Thomas brought up. That doesn't work today because we don't have the concepts of signals. Now we can use like pull one off, we know WASI pull one off potentially to go do that, but we would have to extend the runtime and extend the semantics of that. Maybe we would have to add a new interface to support signal handling. Maybe not. There was actually an old call that was actually taken out that actually performed this. So maybe we bring that back. All of those could be potential discussions if we deem signal handling to be useful. And then again, if you look at the whole world of signal handling, there's a lot. if you've ever done any research and how that's guys spent some time looking into this, and Thomas and I had good discussions on this, there's a lot there. We don't need most of it. Again, this is where being practical and pragmatic are helpful, right? And so what is the correct subset of that? And so maybe there's a small addition that we need to add. Maybe we can do most of that in libc. Maybe we have to potentially also add an API call that the runtime supports, right? And so I think those are the kind of discussions that we're going to have over the next few months to say, hey, are there any gaps that we're missing? P1 does not include threading and does not include sockets, but almost everybody implements threading via pthreads, and almost everybody has a socket-like interface that supports the Berkeley socket APIs. So I think everybody sort of already acknowledges that that probably needs to be part of the LTS extension. The other stuff, that's something we'll have to debate. And I think it's also going to come down to who's going to build it, right? So if we do decide we need to have signaling, there needs to be a champion that says, yes, I really need it, and I'm willing to throw some resources, and I'd like some other people to help me, but we need a champion for those kind of things. The other thing, and we haven't gotten to this yet, but is as we're looking at these additions, we also need to understand like what's the path forward. When WASI 1.0 becomes a thing, what happens to that signal handling? Does it go away? Maybe that's the right answer. Maybe not. It's probably not the right answer, because I'm sure signal handling will still be a thing in 2026 or 2027. What's the path from here to there, right? And so that's another part of that story that we have to sort out. So. Make sense? Merlin.
So I think the first time I heard about this initiative, it was presented as WAMR LTS instead of WASI LTS. What's the decision there to rebrand it as WASI LTS? I feel as if we might be stepping on the W3C's toes as the bytecode alliance.
I've never talked about this as WAMR LTS, although WAMR has been like the one runtime I think we all agree needs to be supported, and I think it's the one runtime almost all of us are using exclusively. We have had discussions with a lot of folks in the Bytecode Alliance about this being a WASI P1 LTS, and so far no one has really complained about toes being stepped on. I think the reality is we don't want to stand in the way of progress for what's going on in WASI current, right? P2, P3, component model, a ton of great work going on there, right? But at the same time, a lot of us want to build on this technology today. And so what I have seen this received as, this is a pressure relief valve to allow them to go forward and potentially even make more breaking changes and push the envelope on that stuff, because there is a stable base to use this stuff today, right? And so I've seen this be pretty well accepted, but we are limiting this into like what tool. Well, you'll see this in Chris is gonna actually. Why don't I just go to this now, because Emily asked. What are the runtimes that we support? We're looking at runtimes being WAMR and potentially WASM to C, just so that we have some cross compatibility. But even within that, for WAMR, like which platforms do we care about, right? Windows, maybe, but definitely not on RISC-V, because there's no such thing as Windows on RISC-V. But even if there was, we wouldn't support it. But when you start looking at this, we're trying to limit this to as much as possible to make because obviously we all have to provide resources to support this, right? And we don't have a team of 1,000 people to support this. So we need to be very pragmatic about what we're supporting. And if somebody really feels very, very, for example, like RISC-V, really feel they need this in the embedded space, then maybe this no turns to a yes, but somebody has to champion that, right? And so we're trying to keep this, again, to avoid that stepping on toes, we're trying to keep this as limited as possible, if that makes sense, Merlin.
Yeah, maybe I could also add that a very basic understanding was to help each other in terms of give feedback, provide requirements, such that if you have a P1 LTS, that the insights get looped back into P2, P3, whatsoever may come next, such that both approaches can converge at some point in time. However, there's no guarantee and commitment that everything will be dropped in order to make it converge.
Right.
Right. So there is the understanding that there is still a risk that there is some diverging processes that could happen, but this is not what it is about. So the understanding is to avoid that. Yeah, as long as it could be.
The discussion I had with lots of people at WASM.io, but I think Luke was in the conversation, Dan was in the conversation. Like at the very minimum, like whatever code you have working on WASI P1 LTS, at the source code level, that should compile when they finish 1.0, right? At least for C and C++ and Rust and all that, with minimal changes or no changes. I think we can strive for something better than that, right? So we get some sort of binary compatibility. Maybe there's an adapter that comes in. Maybe there's a way to say, hey, I have P1 methods, and there's a way that we can, either transform the binaries or have an adapter or a shim to do that. But at least at the source code level, that needs to be consistent. The other thing Thomas said is also really important too, is about contributing upstream to fix things. So, WASI libc, I don't know if anybody's paid any attention as to what's in WASI libc, but it's a lot of work, right? It's basically muscle, the libc library, with all the kernel calls ripped out and replaced with WASI calls, right? That kind of sounds simple, but it's actually a lot of work to go do that. Also, when you start looking at things like pre-opens, right? Those are things that have to be and whatnot. And so there's a lot of work that's been done there, and there's not a lot of resources that actually, I don't know of any resource that is dedicated on any team 100% to WASI libc. And so the more people we have contributing to that, the better that's going to be, right? And so wanting to contribute that back. So if we're fixing something for LTA, it's really nice if that same fix can also fix something automatically in P2, P3, and 1.0, or if they can take the patch that we have and apply those to that source code branch if it's a different branch. And so that I think is huge, because again, the more we're spending time and resources on this for P1, then we want that to also benefit everybody else that's on the current tip. So.
Okay, I think that makes a lot of sense, and I like the way that this is framed. I also know that for our interfaces, we would be happy to change our P2 proposals to maybe make them more compatible, or maybe improve them based on what we learn from this exercise.
That is a whole different other topic that I don't think is in this document, but since you kind of alluded to it, things like, I think what you're talking about, like GPIO and I2C and things like that, there's some P2 interfaces that have been proposed. That's great. We don't have a way to translate that back into P1, right? Because obviously you don't have WIT. And so there is this question of, is there possible for us to craft those in a way that makes it easier for us to go back and forth, either mechanically convert the WIT into something that can work on our side, or handcraft them, or what? I think that's a big open item as to like what we need to do or what we can do there. But I think that would be really interesting, because again, that would allow us to use some of these things in the P1 context, potentially in production, and then feed that input back to P2, P3, and eventual 1.0. So good. All right. Synchronized tool chains and runtime. So what do we mean by that? If you look at how the project works today, or how things work today, is you have the WASI SDK that gets released on some cadence. There, I think they're only using major release numbers, right? And so it also turns out there's a bunch of upstream dependencies for WASI SDK as well, including Clang. So there's changes that happen in Clang that eventually get pulled in. And so how do we manage that, right? Like we may actually, in the LTS sense, may not want to take the latest Clang version, right? We may actually want to stay on an older, more stable version, and then only upgrade at a specific point, right? And so whereas the folks working on, WASI current may need new Clang changes, right? Because some new feature has been released and they need that support right away, right? And so we want to be able to synchronize that. Separately, we have the runtimes, right? So we have the compiler, we have libc, and then we have the runtimes, and there's no synchronization between those. There's no guarantee that like 2.1.4 of WAMR is going to work with WASI SDK 25. It does work today, by the way, because that's what I'm using, but like there's no guarantees on that. And so figuring out how to synchronize those better, not saying we have to use the same version number, but at least say, here's the current supported versions, and then here's the current dot versions that are supported underneath that. We also, as I mentioned before, we're kind of limiting scope. And so let me talk a little bit about this. I've been talking a lot about C and C++. I care mostly about C and C++. But turns out there's a lot of people out there that like Rust. And so, we're trying to figure out what makes sense from what's included in LTS. And obviously each language is a different tool chain, potentially. Not always fully, because we try to use LLVM underneath the covers, but a good portion of that, like the standard libraries are unique. So right now we're proposing WASI libc, sorry, C and C++ and Rust. So WASI libc and then standard lib from Rust. Go is not on this list. Go, TinyGo. It might be something if somebody really wants to do this. I know Ron would probably want Go to be included in this. But for now, these are the ones that we've limited. So I think this will be an area where if somebody has a real passion around Go, might want to chime in. But again, making sure that there's at least we're very clear about what goes with what and what's supported with what, right? Because again, as we support this over a period of 5, 10, 7 years, or 5, 7, 10 years, whatever that period is going to be, it's important, right? Especially if you want to be on a specific tool chain version or a specific runtime version, you want to know what goes along with that and what path I'm on in terms of supporting that from a patch perspective. In terms of the artifacts, I think I talked all about this. So WASI libc, Rust standard lib, the Rust C compiler, the client compiler, and then the runtimes of WAMR and WASM2C. It would be nice if we had another runtime in here as well. I think WAMR is the one that most of us care about. It's the one that's most widely deployed in this space. WASM2C is an interesting runtime, or an interesting runtime, because especially in the embedded space, it could allow us to build really, really small, convert WebAssembly into really, really small and tight code that can run on very constrained devices. WASMCon last year had a pretty awesome demo of this running, I think in like 6 or 12K of memory, like a real WASM program, which is kind of cool. So I think that's interesting, but it would be nice to see, I don't know, WASMer, WASM Edge, potentially even WASMTime support this as well. So again, each of those is a multiplicative amount of additional work that we would have to do. So, we're going to take that from a pragmatic perspective. Does this seem reasonable to everybody? Is there a major miss here? All right, good. And then Chris took a stab at kind of selecting out even a subset of things like WAMR, right? Because WAMR obviously is supported on a bunch of different platforms. The one I care about are Linux and Zephyr. And that's the one we actively use. Sony uses NetX, so obviously you can see there's a interest here. There's also Windows and Mac OS because people use that for development. Right? So Linux seems to be the most broadly supported. Zephyr, we had some discussion. We narrowed this down to ARM32 and Extensa. So this is the ESP32 folks. A lot of folks using ESP32s. Everybody in the embedded space is pretty much ARM32 today. There are a few platforms that are ARM64. So Chris added this. This one might be something we can go away, although I think the additive support between this and this is not so big. NetX today, again, used by Sony, I think is only on these two platforms. And then obviously Linux is used everywhere else. WASM2C doesn't have that same thing because it generates ANSI C, so you only need a math library and a C compiler. So this is for WAMR and the runtime. The other thing that we talked about too, again, selecting this down, is limiting the supported platforms for tooling, right? So it's one thing to say, hey, we support Clang, but like you need Clang compiled for your thing. So if you have a, you know, my first project as a commercial software engineer was Windows on MIPS. I'm pretty sure we're not going to get a MIPS version of the Clang C compiler to run on my Windows machine. I don't have that machine anymore either, but so we limited this down as much as we can to Windows, Mac OS, and Linux. And again, ARM64 and x86 were those platforms supported. BSD is not on this list because we didn't see, nobody was really saying that that's a necessity. I actually don't think it's going to be hard if we actually had to support that, because Mac OS is squint FreeBSD at its kernel. But if anybody's out there using BSD as their main development platform, let us know. Any questions on that? That all seem reasonable. I don't think these are really controversial, but.
So maybe just a question about the Windows. During last EU Asia Sync, we talked about using WSL for Windows support, since most embedded engineers use WSL. Is that the idea, or is the idea to actually provide native Windows support?
This is native Windows support. At least that's what this was for, but let me put a comment on this. Let me get my cursor back from where the heck it went. Add a comment here.
Well, I think my question would be the other way around, but like, do we actually need to support Windows native? Sure.
So what I would say is probably, but I would actually be okay. And actually, I've recently switched to do everything on Windows under WSL. The support is really good. If you had to do this in a VM, it gets a little bit of a pain, but WSL I think is what a lot of folks are using today. The one issue that we used to have in the embedded space is a lot of my devices need to be programmed over a USB connection. And there's a great solution for doing that under WSL now that works super reliably. So that sort of closes that last gap. There might be some folks though that do native development under Windows. And so it might be something we need to support, but I think it's a good question to do.
The thing that came up I guess in a couple meetings ago was that inevitably, if you need to demo this to a customer who mostly does development via some GUI that is ancient and only works on Windows, they only have Windows set up. So even if we keep it as like a little bit more of a canned repository, I think having the option to run on Windows could be important for demoing. And obviously this is something that can evolve, because I think for development, Merlin's right, WSL is the way to be, but potentially for demoing things, it'll need to work on Windows.
Yep. All right, I'm just putting a note in here so we can discuss it, but hopefully I captured that. So reducing it down to WSL would reduce the support matrix, because WSL is really just a Linux thing. But to your point, Emily, there are some existing tools, particularly GUI tools, that only run on Windows. So. Good. Any other thoughts, questions on that? Cool. All right. So this last section, I believe it's the last section, could be wrong, is really about the support for porting software over. So as you know, most operating systems and a lot of embedded code are written in C. So it's true for Zephyr, Windows, Linux. Not quite true. There's actually Rust code in almost all of these now, but we'll let that slide. There's also a huge amount of software written in C, or things that expect a POSIX-like libc underneath the hood. Even some of the Rust code, generally built on top of a libc bridge. So at the moment, current WASI standards provide a subset of this functionality, which is good. But as I mentioned before, there's a number of things that are pretty core that are missing, sockets and threading. Shared memory signals and IPC are other things that are commonly used and are not supported under P1 technically. That said, WEMR does have a way to share memory, right? There are some emulated signals in WASI libc, and IPC can be faked with sockets, but we don't actually have sockets. So, but these are some of the things that we need to do. So Chris went through and said, hey, what are the things that we really need to add? And our thinking is, if we're adding core Berkeley sockets, some basic threading, ways to share memory, so share memory between the host and the runtime or vice versa, and then either have some sort of subset of signals and some IPC mechanisms, that's going to give us a good 90+% coverage of what software needs out there. Right? And so I have not gone down to all of this, not reviewed all parts of this yet. So some of the stuff is new since I reviewed it last. But one of the things that he said is, it's common for embedded systems to be based on Linux, and so Linux as a target is a pretty good thing to view. Now, obviously, Linux is a much larger API set, full POSIX. Well, it's not POSIX compliant per certification, but it's the de facto standard. So again, aiming for 100% of that doesn't make sense, but looking at a good core practical subset of that does, right? And so things again like ePOL are so widely used for good reasons. Those are the kind of things that we potentially need to look at. Is everybody has anybody looked at Wally? Have you seen the Wally project?
Yeah.
Okay. That's an interesting one. Actually, yeah, Emily, you talked to Ben, so I'm sure you've talked to Ben about this. I think it's Ben and his graduate students at CMU were the one that did the initial work on Wally, correct?
Yep. Yeah. Really talented grad student.
Yeah, it's fantastic. So basically, they just said, hey, instead of if you look at the kernel API calls, right, and just provided a way to be able to call them from WebAssembly, you would get a lot of compatibility. Now, obviously, that's a trivial thing to do when you're running on Linux because it's a pass-through call. Gets more challenging when you try to do that on Zephyr. Although that said, Zephyr has a very compatible API set to Linux.
Have you read the paper? I
have.
Okay, yeah, because they did that on Zephyr.
They did WASI as well. So they took the same so the Wally is the Linux kernel interface on Linux reflected into WebAssembly. WASI is the same thing with, from what I understand, the Zephyr kernel interface, not the Linux kernel. So what I was saying is, if you want the Linux kernel interface on a Zephyr-based operating system, that would require a little bit more work. Right?
Yeah, you have to do more of the transformation understood under the hood. Okay, yeah.
Sorry. But yeah, but anyway, his point in looking at this, and there's actually some really interesting concepts around this, is it gives you a lot of portability, especially if you're running on Linux, which a lot of people are. But it also solves a couple of other interesting things. So if you've looked at WASI libc, it's basically Muscle, which is a libc on top of Linux, and they ripped out the kernel interface. The challenge with that is they had to handcraft that interface into WASI P1. So for example, fd_open is the call in WASI. That's not the same as the kernel call. So there's a custom code that had to be written. And when a new version of Muscle comes out, people have to then transfer that and port that over. And that's turns out to be a non-trivial thing because the Muscle team is only targeting Linux. So there's no portability layer there, right? One of the nice things about the Wally approach is it takes away some of that. It moves the challenge elsewhere, but it's interesting because it would allow us to potentially just natively support something like Muscle or potentially even glibc, right? Trying to think what else. The other thing that I think that's interesting about Linux is they've done a bunch of really interesting things and interesting extensions that are not part of the POSIX standard, and I'm not part of the POSIX standards body, but I would say probably should be part of the POSIX standard. So for example, signals are really weird and strange in how they're handled, but Linux has a signal FD call, which allows you to get signals as a normal file descriptor. So you can do select and pull and epoll on them, and then you get them. And so you don't have the weirdness of stopping execution and then have this, and then I'm calling in on a different stack with a limited thing, and I can call these functions, but not those functions. Like all that weird stuff with signals, that kind of nicely kind of sidesteps that, but gives you that signals functionality. They've done something with IPC called Event FD. They've done this with timers as well, because timers have an interesting callback mechanism as well. So looking at some of those extensions on the Linux side are really interesting because it could give us a way to solve some of these things nicely, and not have to really change and create a whole bunch of really weird oddities. Because again, if you look at signals were in WASI P1 early on. There was and that support was removed. If you go look at and go read through the, I think 140 different comments on that GitHub issue, there's a lot of complexity in signals, and the reason why it wasn't included is solving all of that was deemed just a huge amount of work, and especially trying to get full coverage, right, for signals. So that work was kind of put a pin in. We'll deal with that later, right? So if we're trying to provide compatibility, we got to go understand that context. But looking at what Linux has done here is kind of an interesting idea. So. And then last but not least, future
So
migrations. And then put them up.
I have a question about the
Sure.
guidance for portability. So for our interfaces, where possible, we actually looked at existing hardware abstraction layers and built the interfaces to mimic the widely available hardware abstraction layers instead of Linux specifically. In terms of USB, for example, we mimicked libUSB, which is basically the main implementation. For I2C, we used embedded HAL as the interface instead of actually looking at how Linux implements it. I think this might be a good suggestion to choose like either Linux or maybe a widely accepted hardware abstraction layer as inspiration for how we should do functionality.
I think that's quite astute. And I think that's similar in inspiration to what Chris intends here as well, right? Where there is a suitable, well-defined standard, let's go adopt that standard, right? I think the example here was that, hey, Linux has done it right for a lot of things, and Linux is so ubiquitous. The default of saying, hey, do what Linux does is probably the right answer. But I think that's absolutely spot on. Just so I get the notes correct here, what was the USB library?
libUSB.
For USB. And then I2C was embedded HAL.
Yep.
Okay. I'll put the notes. I'll make these more readable later when nobody's watching my screen. But I think that's exactly what he's intending here, where there's a commonly accepted standard. I'm doing some work with another group, and there's some discussion around CAN. And one of the things that we discovered is there's a standard called Socket CAN, which basically uses the socket APIs and a couple of other calls to provide CAN functionality over existing sockets. So all the reading and the writing and all that happens over the socket API, and you can just select and pull and all that fun stuff. And then the configuration is like a handful of functions. And that is something that is a standard, and it actually has been implemented. And that's what most things on Linux use for CAN, from what I understand. And most of the drivers also support that. So that's really good because it makes the runtime implementation easy. But then also porting the software is also easy. So you get kind of that double win. And luckily, Zephyr has adopted that as well. So again, that's a nice standard there. And I think libUSB is that I'm assuming that that's what's on Linux as well for the default USB, correct?
So Linux basically has two layers of USB drivers. There's just the generic driver for what would be for the controller, which is in the
Gotcha.
Linux kernel. And then libUSB is basically between the Linux kernel and your application using USB, implementing a user space USB driver.
Right.
But then libUSB can translate also to WebUSB. It can also translate to Windows, to Mac, to some real-time operating systems, I think.
Oh, nice. Yeah, no, I've used libUSB on Windows for some software, and that was my understanding. It was the same API call. So yeah, so something like that I think is a great example. Right? Yeah. Good. Any other comments on this? All right, good. I'll do that comment after. Last but not least, I think this is this is close to the last section. This is where we don't have answers yet, but one of the whole points of the LTS is to also provide a path forward to whatever eventually becomes 1.0. Today, that's going to be something based on the component model, based on the current trajectory. So we need to understand what that looks like. So if I've invested and I've spent 5 or 6 years writing and supporting code in production on the wonderful stack we're going to produce, and then it reaches end of life, what am I to do? Right? What's my story? And I think that's what we have to have a story for folks to do, right? A key part of every LTS is like, what do you do next? Like, what's the migration path? And that's going to be migration guides, potentially tooling, maybe source code or binary shims, things of that nature. And so that covers everything that we talked about before. So it's like, what's the version of if I'm on some old version of Clang because that's what I was using on LTS, and then there's 6 more versions as the current one. Well, how do I go for that, and which version do I select, right? And so we need to kind of sort that out. And then also, what happens with these interfaces? If I was using these other interfaces now, do I have to change my source code? Is there a way for me to run my old code on the new runtime? If not, what's my path there? What's that story? And so I think here's where we have a ton of questions. And it's also, I think, where we're going to have to fill this out later and in the future. Mostly because, WASI 1.0 is still a moving target. So we don't actually know what we have to hit just quite yet, right? So I think this is going to be something that we'll probably have to start, we'll have to think about now in the back of our minds, but it's going to be a little while before we can take any practical steps for it. I think the other thing too is we're talking about WASI P1 LTS. There's probably going to be a WASI 1.0 LTS, I'm assuming, because all of us who love stability and want to go build on something, when WASI 1.0 comes out, we're going to have exactly the same problem. So I think this is actually a good dry run for what a full production WASI 1.0 is going to look like, and then a 1.2 and 1.1 and all that fun stuff. Some of the other things that we've talked about what we're doing and what we're going to do. Verification, I think that's something that we do have some verification today in WASI and some of the tools, but I think we need, from an LTS perspective, that needs to be stepped up. One of the things I'm trying to do is figure out, like, hey, what are the POSIX API calls? What are the libc API calls that I can call that are actually supported, right? And then sort of subset of that is some of them, like select, today only works for files, doesn't work for sockets, right? Because sockets aren't supported, right? So that's not a full support of select and pull and whatnot. And so I think what we want to be able to do is understand what works and what doesn't work, and then once we know what works and what's supported, have some testing around that, right? Have some validation, some test runs. Fortunately, Muscle and a bunch of those other things, they already have libc verification tools and test suites and whatnot that we can use. The WASI libc folks and WASI SDK projects are using some of this already, right? So we can do that, but again, want to add to that. And again, as we move forward as WASI moves forward to 1.0, these tests should like roll up into that as well, so that they can take advantage of that verification work. Documentation. I think, let's see, I don't know who's the newest in this group, but usually when somebody starts getting into WASI, like it's all questions. Like you discover WebAssembly, you go look at some demo, like, oh, that's awesome. And then you start getting involved in the group and you're like, oh, Batman, this is tough, right? Understanding what works, what doesn't work. You know, we talked about debugging before. If you've never set up debugging with WebAssembly, it's a bit of a dark art until you figure it out. And there's a lot of information out there. Some of it is incorrect because it's dated and it worked on an older version. Some of it only works on the component model. And so I think for LTS, we need to bring together like what you can use today and then have that set of documentation that is maintained and kept proper. Again, there's a bunch of stuff going on in the component model, and that documentation is going to be fluid until a lot of those things start getting more firmed up and whatnot. That's a different effort than what we're trying to do. So we need to say, hey, you know, there's WASI current and then there's WASI LTS. And so from a documentation perspective, I think that's very important. And then the other thing is what is how are releases done? And I don't think we know the answer to this question, but I think we all want to understand, like, do we release every quarter? Do we release once a year? Do we have point releases? Do we have bug fixes? Do we have security fixes? How do we track those? How do we release those? How are those numbered? How are those versioned? Whatever and whatnot. And that goes for everything: binary, source code, documentation, verification. So, and then there's a wish list. This document keeps getting longer every time I read it. I don't think we'll go through all this. Yeah, there's a bunch of stuff here on the wish list. Is like, hey, we should probably have CI/CD if we're going to be doing releases and tests. So, all right, Emily, I think we are kind of failed on Chris's estimate what the work is and whatnot, but I think this is probably a good conversation.
I found this really enlightening.
I think if I go back to the table of contents, we had a table of contents. I think what we're going to have to start doing first, if we're going to kind of bucket this, and I know we got 4 minutes left, so this is not going to happen fully here, but I think if we were to sort of look at this first and say, okay, we have like the WASI SDK and WAMR, right? Need to figure out like, okay, what version are we going to start or iterating on and saying this goes with this? So I think there's a bit of understanding what's our first take at, like, what version of this would we want to start targeting, right? Because there's a lot of work going on in, you know, WAMR's done a lot recently. They're adding a lot of new features. I know they're focusing mainly on stability, but, you know, where would we start doing that? Would we pick a particular release of WAMR and say, okay, we're going to start with 2.4.1, which is the current version today, and then, you know, are we going to synchronize releases with that? And then the same thing on the WASI SDK side, right? I do know a number of changes are being proposed around the binary format with Lime 1. I don't know if anybody knows if Lime 1 just sounds like a flavor of a Slurpee. It means linear memory. I think it's linear memory proposal 1, abbreviated to Lime 1. It is basically core WebAssembly plus a couple of additional features. I think reference types. If you search Lime 1 WASI, there's a page that describes this much better than I can remember. There is a proposal to roll things under these labels for WASI. And Lime 1 is the first of such label. And then the reason why that's important is at some point they want to roll the WASI SDK and make that the default for the SDK. As I understand it, WAMR does not support Lime 1 today, but I think they just checked in something that will. There's like one thing that they don't support. I think support was just added for that with Lime 1 anticipation. So these are the kind of things we kind of. I think first sort of pragmatic stuff is to sort of figure out some of this stuff to say, hey, you know, do we stick to WASI SDK 25 and WAMR, you know, blah blah blah, or do we adopt Lime 1, right? So I would say that's kind of the pragmatic thing. So
currently, from what, if I understood it correctly, then the WAMR team confirmed to add support for Lime 1.
Okay. Yes. I believe they confirmed support, and I believe that is now in main. I don't think that's in the latest release. I was looking at the check-ins the other day, so we may actually already have that. Now, the downside of that is that going to work for people who already have existing runtimes in the field that have production code? Because that might be different. So, so I think understanding what our first take at that is and the starting point, and I think we're going to have to just build this out iteratively. I think the next thing that we're going to definitely have to do is really focus on WASI libc, particularly around threading is in there today, and there's actually a WASI libc WASM32 WASI pthreads CMake target in the current SDK, which adds pthread support. And if you've enabled that at WAMR, that just works, and I believe it also works on WASM time. Sockets is not added. So I think that'll be the next thing. How do we get socket support? And what does that look like? WAMR does this through some additional files you have to add and change your source code. So that's a little bit more problematic. And then I think there's a huge step around like the test suite and builds, right? I think one of the things that we're going to have to face very shortly is how do we build an LTS version of the SDK? Because socket support is not part of the standard, and therefore we can't put that in WASI libc because that's a W3C maintained repository. There is a Bytecode Alliance fork of that repository, and also of the WASI libc and WASI SDK. And so some discussions I've had with folks is like maybe they're totally stale. Nobody's updated them because they were just mirrors of the public W3C one. But it might make sense to say, hey, we have this here, and we have, we're doing builds off of that, and then additions happen on a branch on that one. So I think some of those mechanics we need to sort out, and then I think the other thing too is what is the release process. So I think there's a whole bunch of process stuff that we're gonna have to do, and there's obviously a lot of engineering we have to do. So we're out of time, or actually over time. I think what we can do maybe, Emily, is I can take whatever you managed to capture from that rambling in notes, and maybe Chris and I can create a spreadsheet with kind of these items, and then we can distribute it via email and have everybody kind of chime in. And maybe getting that list together first might be the first step to get Chris what he wants and needs.
Sounds good. I've got, I'll send these over.
Okay.
One question,
Sure.
Steven, did you frame also what we gonna do then with the document? So in terms of for what is it needed also? From my understanding, it is also to enable everyone outside the world, and of course the ones in the SIG embedded, to take the document and trying to find out which kind of resources need to be provided in order to make LTS a reality.
I think what you're talking about is so that we can talk about this internally at our own organizations and
Right.
ask for resources, money, and funding and things of that nature. Yes.
Correctly.
Yes, but so I think we need to get a good draft of this document so that people can do that. I can't do. So we as a group really can't do that because that's individual for every company and organization we represent. But I think you're right. I think finishing this document off in the next week or so that we can use this internally, I think would be a key. And so maybe that's an action item, Emily, we should put in for maybe Chris and the SIG embedded admins or co-chairs to work on getting this document kind of signed off and everybody agree on it.
Because you already mentioned that at some point if you need some championing for specific tasks, action items whatsoever, and therefore everyone must be aware, okay, what does it mean in terms of efforts and so on and so forth.
Yeah, and I know we're a bit over time, and I appreciate everybody staying, but I think Merlin, one other thing that might be interesting is I know that there's a lot of grants and whatnot in both the EU and the United States and other places around, cybersecurity, improved software, improved reliability, and things of this nature, where the LTS actually is a good story here, right? If you look at WebAssembly in general, taking existing C code and running it in a, well managed runtime is actually better than just running that on a device natively, right? And so there might be some interesting opportunities for us to potentially seek some grant money or fund some grad students or get some money to fund grad students to do some of this work in partnership with maybe your university or other universities. So if there's opportunities there for us to go do that, maybe that's a good conversation for us to have in one of these calls.
Yeah, I think that's a good idea. I don't have any opportunities that we're currently applying to, but I think it's a good idea. The closest we have right now is that we're trying to find funding for confidential computing with WAMR on edge and IoT devices. But this might actually also be an interesting one.
Yeah. It's something that Chris and I just talked about briefly about like looking at some of these, and he had some suggestions of potential grants or people looking for proposals. So that would probably be
Okay.
a good thing for us to put on one of these future ones. Or like, hey, what are the current call for papers, call for research proposals that we could potentially submit? So
Yeah.
that'd be great. Good. I apologize for going over, but that's kind of what happens on almost all these calls. So I appreciate everybody's time. Any other issues before we wrap? All righty. Well, I'm going to stop recording. I appreciate everybody's participation. We will have this one again in 6 weeks, but there'll be another one in 2 weeks. And then I think everybody, there's a the WASI SG call is on Thursday. So we'll see you all there. All right. Thanks, everyone. Take care.
Thanks,
Bye.
Stephen.